Welcome to the latest Mango Report. Chapter 1: The Strange Dream of Self-Correcting Machines. Human civilization rests upon a remarkable ability: we can recognize our mistakes. A scientist revises a theory after new evidence emerges. A judge overturns a ruling. A child touches a hot stove once and learns not to do it again. Our intelligence is not merely the ability to think, it is the ability to also doubt our own thinking. As artificial intelligence grows more capable, we are attempting to endow machines with this same capacity. We call it self-correction, the ability of an AI system to inspect its own reasoning, identify errors, and revise its conclusions. But this raises a profound question. Can a machine that generates mistakes ever become a machine that reliably corrects them? And even more fundamentally, can we build systems that are genuinely trustworthy, or will trust always require something machines cannot possess? Chapter 2: The Mirror Problem. Imagine standing in front of a distorted mirror. Everything you see appears normal because the mirror itself is bent. No matter how long you stare, you cannot discover the distortion by looking only at your reflection. This is the central problem of AI self-correction. An AI model can review its own reasoning. It can critique itself, generate alternative answers, and even assign confidence scores. Yet all these processes emerge from the same underlying model of reality. If the model's understanding is flawed, its self-correction may simply become an error examining another error. A machine can become trapped inside its own misconceptions. Humans suffer from this as well. We call it bias, ideology, or dogmatism. The danger is that increasingly intelligent machines may become extremely persuasive while remaining fundamentally mistaken. Intelligence is not the same as wisdom. For centuries, philosophers have distinguished between intelligence and wisdom. Intelligence answers questions. Wisdom questions the answers. A calculator is intelligent in a narrow sense. A chess engine is intelligent within its domain. But neither possesses wisdom, because neither understands the limits of its own knowledge. Trustworthy AI may ultimately depend less on making machines smarter and more on making them intellectually humble. A truly trustworthy system might frequently say, "I don't know. I may be mistaken." This conclusion requires more evidence. Paradoxically, the most trustworthy AI may be the one that doubts itself the most. Chapter 3: The Epistemological Crisis of Machines. Philosophers use the word epistemology to describe the study of knowledge. How do we know what we know? Humans possess multiple ways of validating truth. Experience, observation, social consensus, scientific experimentation, memory intuition. Large language models possess none of these directly. They predict patterns in the language. This distinction is critical. An AI may generate a sentence that looks like knowledge without actually possessing understanding. A model may tell you that Paris is the capital of France and be correct. It may also confidently invent a historical event that never occurred. The machine does not inherently know the difference. Its confidence and its correctness are only loosely connected. This is why trust cannot simply be engineered through larger models and more data. The problem is philosophical before it is technical. Chapter 4: Building Machines That Distrust Themselves. Perhaps the future lies in creating systems that are not singular intelligences but societies of intelligences. Imagine an AI architecture composed of one model generating answers, Another model criticizing them. Another verifying facts. Another searching for contradictions. Another estimating uncertainty. A kind of digital republic where no single mind is allowed absolute authority. In human civilization, our most reliable institutions are built this way. Science depends on peer review. Democracy depends on checks and balances. Justice depends on appeals and oversight. Perhaps trustworthy AI will emerge not from perfect intelligence but from institutionalized skepticism. Chapter 5: The Infinite Regress of Trust. Yet an even deeper problem remains. Who verifies the verifier? If one AI checks another AI, what checks the second? Eventually, every chain of trust reaches an endpoint. For humans, that endpoint is often reality itself. Experiments fail. Bridges collapse. Predictions succeed or fail. Reality corrects us. AI systems, however, live largely inside worlds made of data and symbols. Without sufficient contact with reality, self-correction can become an infinite hall of mirrors. Machines may endlessly debate one another while drifting further from the truth. Chapter 6: The Possibility of Artificial Wisdom. Could machines one day become genuinely trustworthy? Perhaps. But only if they learn something humanity learned painfully over thousands of years. Certainty is dangerous. The greatest scientists are often the most cautious. The wisest philosophers are comfortable with ambiguity. The best leaders understand their own limitations. Trustworthiness may ultimately require machines that possess not only intelligence but a kind of synthetic humility. Machines that understand, I may be wrong. That simple sentence could become one of the most important innovations in the history of artificial intelligence. Chapter 7: The Final Paradox. The dream of AI has often been to build machines that think like humans. Perhaps the greater challenge is building machines that doubt like humans. Because trust does not arise from perfection. It arises from the capacity to recognize imperfection. A self-correcting machine may never become infallible. But a machine that continuously questions itself, seeks evidence, welcomes criticism, and admits uncertainty may become something even more valuable. A trustworthy partner in humanity's search for truth. And perhaps that is the future we should pursue, not artificial certainty, but artificial wisdom.